Hey everyone, the purpose of this video is to go through a couple problems in the solutions problem set. So let's jump right in. Problem number 4. If I have 10 grams of calcium carbonate in a 500 cubic centimeter solution with distilled water or deionized water, what is the resulting molar concentration? All right, so molar concentration, the units are moles over decimeters cubed, and so that's my target unit. So my starting unit is grams of calcium carbonate. And of course, I remember my common polyatomic ions. The carbonate is CO3 2 minus. And so the calcium carbonate compound, calcium forms a Ca2 plus ion, would be CaCO3. And I'm going to need to convert grams into moles. And then I'll also have to convert separately cubic centimeters into decimeters. I'm going to have starting unit, final unit, moles of calcium carbonate, and then separately I'll have to convert centimeters cubed into decimeters cubed. All right, so let's start with this grams to moles conversion. The conversion factor for grams to moles is, of course, molar mass. So let's go ahead and calculate the molar mass. So Ca is 40.08, and C is 12, O is 16 times 3, and I'm just going to put that in my calculator. All right, and I get 100.08 grams per mole. Great. And so now I'm just going to set up my dimensional analysis. 10 grams of CaCO3 times 100.08 grams of CaCO3, 1 mole of CaCO3 is equal to, and I get 0.0999 moles of CaCO3. All right, and now to convert centimeters cubed to decimeters cubed, the conversion factor is, of course, 1 decimeter cubed equals 1,000 centimeters cubed. And I remember that because centimeters cubed are the same as milliliters. Decimeters cubed are the same as liters, but of course we use the IB units of centimeters cubed and decimeters cubed. So 500 centimeters cubed times 1,000 centimeters cubed, 1 decimeter cubed, equals 0.5 decimeters cubed. Sorry, struggling to write this. Okay, and so now my concentration will just be my moles, 0.999 moles of CaCO3 over 0.5 decimeters cubed. I still have this number in my calculator, so I use the answer function to do this math, so I'm not rounding early. And then I see I get 0.1998, and so I can round that to 0.200 moles per decimeter cubed is the molar concentration. All right, next problem, number 10. How many molecules of magnesium phosphate are present in 250 cubic centimeters of a 2 molar solution of magnesium phosphate? So, starting unit is, I have centimeters cubed of 2 molar magnesium phosphate. Hopefully we remember phosphate, PO4 3 minus. Magnesium, Mg2 plus, so Mg3, PO4 2. Final unit is going to be molecules, or really compounds, because this is an ionic compound, but compounds of Mg3, PO4 2. And the conversion factors that I'll need, well, in order to get, I'm starting in centimeters, so centimeters to decimeters cubed, because centimeters cubed is not super helpful. I can then go from decimeters cubed to moles using molar concentration. I have a solution, so in order to get into moles, I need the concentration. Once I'm in moles of Mg3, PO42, I can then go into moles, or start in moles of Mg3, PO42, and convert to molecules. And of course, that will be with Avogadro's number. Avogadro's number. All right. So 250 cubic centimeters of Mg3PO4 to aqueous times 1,000 cubic centimeters, again, of Mg3PO4 aqueous, 1 decimeter cubed, again, of Mg3PO4 aqueous. I do encourage you to write that entire thing each time. I just don't want this video to go on and on and on. Then I'm going to use the molar concentration, 1 decimeter cubed of Mg3PO4 to aqueous, and 2 moles, and this time it's moles of just the solute, not the solution anymore. So PO4, 2. Okay, so here, this is volume of total solution. Molar concentration is moles of solute out of volume of solution. And so on the bottom, I have Mg3PO42 aqueous. On top, I have just moles of solute. All right, once I'm in moles of just the solute, well then 1 mole of Mg3PO42, or 1 mole of anything, is 6.02 times 10 to the 23rd things. So 6.02 times 10 to the 23rd, also Mg3PO42 compounds. All right, so I'm just going to put this entire thing into my calculator, and I put it in all together as one operation so that I can check my work and so that I don't have any rounding issues. I get 3.01 times 10 to the 23rd Mg3PO42 compounds or formula units, whatever you want to call them. All right, I hope that helped. Thanks for watching.